Good morning.
Good morning. Good morning.
Hey, this is Chanel. I just emailed you, but I was trying to join the class on my computer instead of my phone, and I don't have a passcode.
Passcode for?
Like, you know how once you put in the meeting ID number?
You talking for Zoom?
Yeah.
Well, you're in here now.
I know, but I don't want to talk to you on my iPhone. I want to talk to you on the computer.
Oh, you should be able to do it. You don't need a passcode.
Oh, okay. Well, I'm gonna hang up.
Okay.
Thank you.
No problem. Let's see, is everybody logged on? It look like it. Okay, good morning, everyone. Good morning. Hope all is well. Hope everyone's doing all right. So yeah, this is Math 130. My name is Mr. Tucker. So hopefully you've been getting I gave shot about 4 emails out. Good morning, good morning, good morning. Shot about 4 emails out. If you haven't seen all 4, we'll look at them in a second. I know at least you saw one of them, and that was the Zoom information. So hold on, somebody's trying to come in. Okay, so let's go to, if you ever in a position or feel like you haven't seen or heard from me in a while, and you look through your emails, can't find a thing, you always go to go to Canvas, and in your dashboard, and go to Canvas announcements, and every email I send to you will always be archived right here in your Canvas announcements. So like I said, even if you don't see any emails, you can always go to Canvas announcements, and that's where all of your emails will be archived. So the first one was the greetings and course description, letting you know how we will be handling the course this semester. So we will be learning virtually, and just playing with words, virtually versus online. Learning online, it's a little bit differently in my mind. If you learn it online, then the instructor could just send you videos and you would learn asynchronously on your own time and everything like that. But when you're learning virtually, it's the same classroom experience as face-to-face. It's just that you're in your room and I'm in my room. So in other words, you're meeting at your class scheduled time. I'll be writing on my board. You'll see it live. You'll hear me talking. You can ask questions, all live. So it's not like you're out on your own. So that's the difference between learning online and learning virtually. Same classroom experience, just that you're in another room and I'm in my own room. You got the Zoom information. All right, and then from here, let's look at required materials. Yep. So here we're talking about registering for Math Lab. You guys have a different course ID. As a matter of fact, I end up having to change the course ID. So I sent you a new email. That was like the last email I sent you guys, a new course ID. So make sure you're using that one, not the one that we have here, but the one that I gave you initially. So if you have any issues with converting that over, if you call Pearson, they should be, not you converting it over, but you have any issues with Pearson converting that over. So you may have to do that if you already purchased it. Wherein I found out that the email that they sent, not the email they sent me, the original book that we had during the summer is different from the book that they use now. And I, didn't know that they switched anything. So that's why the original one didn't match up with what was going on in Barnes and Nobles. So if you already bought it in Barnes and Nobles, you can always call customer service, Pearson customer service, and they should change it for you with no problem. If you're having any issues with anything, always make sure you shoot me an email so I can get to the customer service rep and see what's going on with that. But once again, if you purchase access to Math Lab through the bookstore, they should be able to use it for this new one. Is that why the book was on back order? I'm not sure about it being on back order. I'm not sure about that. I didn't even know it was on back order. So that may just be because everybody's trying to buy the same book. But now when you say it's on back order, is the access code on back order as well, or just the book? For those who are in the chat. Because the main thing that you guys need is the access code to Pearson.
This is what they gave me yesterday.
Okay, that's all you need. Mm-hmm. Yep. So now if you're waiting for the book, that's not the worst thing in the world. It says when you log in that the instructor is not a separate registration. Okay, so now that should have been for the old code. Was that for the new one that I sent? The last one I sent? All right, so I'll check it out when I go in there and make sure, but it should be okay. So we'll look at it in a second. But yeah, so when you go in there, we're gonna go to mymathlab.com, click register now, then use the course ID that evidently does not work for some reason. But when it works, then you have three options. After that, you would actually, after you put in your information, you either use the access code that you purchased through TCC or an outside source, your friend or Amazon, whatever. Or you can purchase access. If you purchase access through Pearson, they won't give you access code. They would just give you the access. And if you're not ready to purchase access or you don't have the access code, you can always use the 14-day free pass, which gives you 14 days free, full access. After the 14 days, they will ask you for, payment for the access. If you don't have it, not ready at the time, they will lock you out. You will not lose any of your progress. Okay, somebody said access code from the new email work, just signed up. Okay, cool. All right. So the 14, excuse me, if you get kicked out after the 14 days, you will not lose any of your progress. Will not lose any of your submissions. I will still be able to see what you've done. It's just that you would not be able to do anything until you actually paid for the full access. All right. So let's look at the other document I sent. All right, MATLAB specifics, basically just a doc letting you know how we will be using MATLAB throughout the course. So you cannot pass the course without MATLAB, without access to MATLAB. That's the first thing. All of our homework, tests, whatever we do is going to be generated through MATLAB. So you have to have access to MATLAB. You must participate in MATLAB to show your activity. That's how I will solidify your attendance. So now we'll be looking at Zoom, trying to make sure I catch everybody, but sometimes I don't do that, especially if you will come in after I've started lecturing. So what you want to do is make sure that you're showing activity in MATLAB. If you missed, let's say you missed both days that we had lecture. Now I'm going to record the lectures, convert it to YouTube, send you the link so you will always have access to past lectures. But the thing about that is if you missed the class, let's say you sit through the lecture on your own time, I would never know it. So the way you will solidify your attendance is by doing work in MATLAB. Even if it's nothing more than going into homework, hitting save and coming out of it. That puts a timestamp on your activity that shows that you were there. And then I have proof and I can go and move accordingly. So make sure that you are active in MATLAB. If you're having any issues with attendance or MATLAB period, if Pearson website go down or something like that, let me know so that I can move accordingly. If I need to adjust due dates or something like that, I won't know unless you tell me most of the time. If you're having issues with attendance or doing work, every semester, every class, I have people that just fall off the face of the earth. So they'll stop coming, they won't withdraw, they stop emailing, they stop doing work in MATLAB, whatever the case may be, and I don't have any choice but to give them an F. So if you don't want me to put you in that category, you have to communicate something. You don't have to tell me deep intimate details, but you should let me know that you're having little issues, try to work it out, and I'll do whatever I can to help you out. So always keep lines of communication open. All right, let's see. You will have unlimited amount of tries to get the best grade possible on your homework. So I'll show you how that works in a second, but your homework is set to unlimited. So when you look at your homework, the scores I'm looking for 75 or better. Because just keep in mind with unlimited amount of tries, there's no such thing as unlimited amount of problems. So really, if you want to be honest, you can keep clicking on it until you get to the problem you just got the answer for where you got it wrong. So to be honest, you can finesse the system, and I do recognize that. So we're at least shooting for that 75. 75 to 84.9 will give you 90 in my grade book. If you want to get full credit, you want to at least get an 85 on your homework. All right. Test reviews are not mandatory. I suggest you at least take a look at them though. They'll help streamline your studies for your test, but they're not mandatory. But if you score 85 or higher on your test reviews, I will add 5 points to that respective test. For your tests that are proctored, that are not proctored, you will get 2 attempts to get the best grade possible. You know, if it's not proctored, that means you get to do it at your own time, you know, whenever you're ready, you know, before the due date or whatever. So you will get 2 attempts to get the best grade possible on your test. Now, your test grades, they are what they are. So if you got a 72 on your test, then you just got a 72. It was the homework that I said that, you know, that I will adjust the grades accordingly. And then you email me your scratch work for any test submission, whether it's proctored or unproctored. Now, you know, a proctored test is me watching you while you take it, and that's, you know, the final exam would be considered proctored, something like that, you know, or, you know, like I said, any other test I say proctored. That's what I mean by that. Questions on anything? Any questions? Anything else said before we go to math lab? All right. Oh yeah, so that new course ID, that was the other one I sent. That should be this one right here, Tucker 22843. So make sure you're using that one. I know a few people said that you couldn't register. Make sure that's the one that you're using. I sent another email out to you guys. Tucker 22843. All right, so let's go out of here. So 130. Yeah, just making sure. So 130. Let's make sure the dates are okay. So you should be able to enroll for this course. So yep. So make sure you're using that same code. That new code that, you know, like I said, Tucker 22843. Let me see, 130. Did I change that date here? Yeah. So if you're using the old code that I sent you, then they shouldn't be letting you in. So maybe you're using the old code for those who tried to register and said that I'm not accepting anyone new. All right. And so, like I said, for those who enrolled, if you have any issues with converting or anything like that, make sure that you get with me so I can make sure you're straight. All right. So going into the shell, 130. Excuse me. All right, click on assignments. Here go all of your homework assignments for the whole semester. And this new shell, you know, they gave us to convert it over. They actually took out some stuff. So that's why I wasn't, you know, I didn't have a problem with it. So it was to your benefit that I go to this new shell. Because they took out some content that y'all don't have to worry about. So I think that's a good look for you. I have to add I haven't finished populating out the shell yet. I don't have any tests or anything in here, but your test would be sitting above this right here in this area. It will be above sample tests and quizzes. Notice that says sample tests and quizzes. Please do not do any of this stuff down here. Pre-test, review, quiz, post. That's not your stuff. It's stuff that's embedded in MathLab that I cannot delete, but your test will be up here. So that's why it says your instructor has not created any quizzes or tests for you. I still need to populate that because, like I said, I had to create a new shell. But all of your homework, though. All right, let's see, that goes into, yeah, awesome. Okay, so let me show you how it looks. We haven't dealt with MathLab before. All right, so this is how this will look. Let me see, I'll put something in here. So put that in there, check. They try to give you a hint. Check again, and then those will give you 3 chances to get the answer correct. Hit final check, the answer is wrong. They tell you what the answer is. You can go to the next question, hit similar question. If you don't hit similar question at that point, you can just close it out, but similar question will be down right here. You can hit that, and that'll reset the problem to something very similar. If you were to go to your homework list, problem list, notice that the first, not first one, but the question you got wrong has a red X. If you get it right, it'll turn into a green check. So the coefficient, what, -20? And so now it's a green check, and it'd be like you never got it incorrect. Okay. So here we help tools, help me solve this. This will walk you step by step through the problem that you're dealing with. Most people don't click on that because that will actually, like I said, walk you step by step through the problem that you're dealing with, and then it will reset the problem that you're dealing with because it just gave you the answer. So most people don't choose that unless they're completely done with the problem. But what you can do is do an example, which is what a lot of people like to do, and that'll go step by step through another problem that's very similar to what you have, and then you can print it out if you want as well. Other examples, you got problems that are more complex will actually have a video of another instructor, a Pearson instructor up there as well. But you can click on the video, it can talk to you about it. Hit textbook, that'll send you to the place in the e-text where you talk about this problem. Ask my instructor, that will send me an email telling me that you have a problem with this problem. If you send me an email and I don't respond to that, I know I've had in the past, every now and then somebody say, well, I did ask my instructor and it didn't go through or didn't hear from me, and I never saw anything. So it's possible that either they could have done something wrong or there was a miscommunication between devices through technology. So either way, if you don't hear from me, then you can always email me the more conventional way, whether it be through TCC or through Canvas. I get both of those just to go back around. And also you can print this as well. All right, so those are your help tools. All right. Questions on that and how Math Lab work? Questions? Good. All of these are not 32 problems. Let me see what the next one, what's the next one look like. Yeah, see, this one's only 14. I didn't think all of them were long like that. I think that one's long like that because it had simple ones like the answer was just 20. The other one was X. So just simple definition problems. So yep. All right. So any questions on anything before we, I guess, look at a few notes. Look at a few notes. All right, so let's go ahead and look at a little bit of notes. So going back here. All right, so we are starting with 2.2. So my old notes, I think my notes had start off with 1.2. Yeah, okay. Problem, same stuff though. So they changed the addition on me. So we're actually starting off with 2.2. And always, if you get in your homework, you have a question on anything, always feel free to ask. Or if you get in there and you see something and you're not sure if we covered it or you feel like we didn't cover it, just ask. We'll just knock it out. It's not that big a deal. But I just want to make sure you're comfortable with asking whatever questions you're supposed to ask. Are we supposed to watching your screen on our own Math Lab screen? No, I was about to convert to, you should be looking at notes right now. All right, so hopefully you guys are seeing my notes, right? See.
Yes.
Okay, cool. Thank you. All right, so let's get into it. Just cover a few things today. Like I said, this is section 2.2 for you, not 1.2. Same title though, symbols and sets of numbers. So we have natural numbers, which starts at 1 and goes on to positive infinity. No decimals, no fractions. All right, so let's just on the due date listed for homework assignments. Oh yeah, glad you mentioned that. I forgot to mention due dates. Okay, so your due dates right now, your due date should be December 17th. I think that was the last day of class. Let's see, I don't have anything in it yet, but anyway, I'm gonna set everything for December 17th. But as we get closer to closing out a chapter, that's when I'll put a due date or set the due date. So I didn't want to put a due date out there. And then let's say we need to move slower or something like that. And then I have to move a due date. So what's going to happen is as we get close to closing out chapter 2, let's say I think close out chapter, I think it's 2.6, 2.7, something like that. So let's say we get to 2.5. I'll say, okay, we're getting closer to closing out chapter 2. Our due date for chapter 2 will be Sunday. My due dates normally are Sundays, blah, 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 blah. And so you will always have a block of homework due at a due date. So whatever our test is going to be on, that's when that homework will be due, and we'll set that date accordingly. And I wouldn't be like, your due date is tomorrow. I will set it out, like a week away, so you'll know that your stuff is due. So now what you don't want to do is wait for me to say a due date in order for you to start your homework. You know what I mean? So we're going to do 1.2 today, 2.2 today. Then, you want to get started with 2.2 soon. Yeah, not a problem, not a problem. Thank you for asking, because like I said, I missed that part. I forgot to talk about that. So yeah, so your due dates will be set as we, progress throughout the course for each chapter that we cover. All right, so like I already mentioned, natural numbers, whole numbers, the difference between whole number and natural number is the 0 is included. So you can think about whole like a real whole and call that your 0. So that would be included as a part of your whole numbers. Integers includes natural numbers, whole numbers, and all negative numbers. So once again, no decimals, no fractions for these first 3 categories. For your integers, though, we're now including negative numbers. So we're going to negative infinity. All right. Rational numbers, any number that can be written as a over b, where a and b are integers. So 3 over 5, negative 7 over 9. And then 8 over 1 would be considered rational number as well, which is a fraction. But simplify that, that's an integer. So all integers are rational numbers. So that means all whole numbers are rational numbers, and all natural numbers are rational numbers as well. So your rational numbers include everything we talked about up to this point. Okay. Oh, also with that rational number, any decimal that is terminal or repeating is rational. So what we mean by terminal, that means it has an end. So 0.75, it ends at 7 at the 5. So that's actually the fraction of 3/4. And then 0.333 repeated is actually the fraction of 1/3. So if your decimal repeats or it is terminal, in other words, it has an end, it is considered rational. So those are all of your rational numbers. All right. Questions on anything? Also, don't forget, you don't have to enable your camera during lecture time. So that's fine. But that means I can't see you as well. So I wouldn't know if you're still writing. So if I do scroll up too fast and you still writing something, you can always either unmute or type in the chat. I was still writing, or can you scroll back up? Something like that. And I'll make sure you're straight. All right. Everybody good? Can I scroll up? So we have rational numbers. Now we're looking at irrational numbers, which would be the opposite of rational. So it's any number that cannot be written as a over b, where a and b are integers. So square root of 2, it's a run-on decimal. It doesn't have an end and it's not repeating. Remember, terminal decimals and repeating decimals are rational. So square root of 2 doesn't have an end and is not repeating. Same thing with pi. That's 3.14157, blah, 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 blah. It'll never end and it's not repeating. Negative pi over 3, square root of 507, just examples of irrational numbers. If you were to throw them in a calculator, they would not be repeating and not be terminal. All right, so real numbers will be all rational and irrational numbers. So you guys are not going to get into imaginary numbers. So everything we talked about up to this point are real numbers, but there are such things as imaginary numbers, so the numbers that are not real. All right, so there's your generic number line, zeros in the middle. All the values to the right are positive. All the values to the left are negative when it comes to your number line. We're talking to the right of 0 and to the left of 0. And we have our inequality symbols, less than, and then greater than. Less than or equal to is less than with the bar under it. Greater than or equal to is greater than with the bar under it. Also, when you look at your number line, let's say if we look at the number 1, everything to the right of number 1 will be greater than it. Everything to the left of number 1 will be less than it. Same thing with -2. Everything to the right of it will be greater than it. Everything to the left of it will be less than it. And that will always be the case no matter what number you're dealing with. Everything to the right of it will be greater than it. Everything to the left of it will be less than it. All right. So first exercise, let me erase some of the stuff, just make sure we're good. You know, some of you may already know this, but just trying to make sure we're all right, walk through it. So it says use less than, greater than, or equal to make a true statement. That's all right. All right, so the way we look at these numbers, these symbols, even if you forget what words go to which symbol, always think about the idea that the mouth is always going to be open to the greater number. So if you can at least establish which number is the greater number, then the mouth will always be open to the greater number. I remember my teacher back in the day used to put the teeth on the symbol because, you know, the alligator wants to eat the bigger piece or the bigger number. So your mouth is always, the mouth of the symbol is always open to the larger number. So we know that 7 is greater than 2. So the mouth should be open to the 7. So this statement reads 2 is less than 7. So we use the less than symbol here. 2 is less than 7. The next one we have 100, and then we have 30. Same thing. We know that 100 is greater than 30. So the mouth of the symbol should be open to the 100. All right. And then -35 and -4. Always think about your money. Just like you would rather have $100 versus $30, you would rather be -$4 versus -$35. So the -4 is greater than that -35. -35, since it's negative, you're further in debt than you are versus having -$4. All right. Any questions on using the symbols? All right. So the next exercise says given the set -2, 0, 1/4, -1.5, -3, 11, square root of 2, and square root of 81. List the numbers that belong to each set. So now when you have something like this in Math Lab, make sure that you use the numbers the way that they give them to you. So let's say you look at 1/4. Well, as a decimal, it's 0.25. Don't put 0.25 in your list. Put it as 1/4 if they ask you to write it out. So just make sure you're careful there. Same thing with square root 81. Square root 81 is 9, but you wouldn't put 9 in your list. You would put the square root 81 the way that they gave it to you. So be careful. So, I already got these written, so we'll just discuss it. So natural numbers, remember, natural numbers are all positive numbers, no decimals, no fractions. So what would fit into that category is the number 11 and the square root 81, which is, like I mentioned before, 9. All right. Whole numbers, the difference between whole numbers and natural numbers is just that 0 is involved. And so since 0 is here, that means we can include it as a part of our answer. So that's the only difference between natural and whole numbers. So that's 0, 11, and square root 81. Integers include negative numbers. So that's why we have -2 and -3 here. But we also have the 0, 11, and 81 as well, square root 81 as well. Rational numbers. That's going to be all of your integers, whole numbers, and natural numbers, but then also include any terminal fractions, terminal decimals, or repeated decimals. So we see that 1.5 is terminal, so it ends after 5. What you can do is, if you want, you can check the 1/4, throw it in the calculator, make sure it does have an end to your fraction. If you don't already know, 1/4 is 0.25, so that works for us as well. And then irrational numbers, the only one that fits the irrational is the square root of 2. If you were to throw that in the calculator, it should give you a repeated decimal that does not end. I mean, a non-repeating decimal that does not end. And so that's the only one that's irrational. And then last one, F, all of these are real numbers. So the whole set would be real numbers. All right, questions, any questions? All right, everybody good? I'll scroll up. All right, so absolute value. It is a counting tool. It represents how many units a number is from 0. And the main thing you need to hold on to is that when you apply the absolute value, the result is always positive. The result is always positive. So taking the absolute value, and that's what these bars represent. You know, the bars represent the absolute value. So taking the absolute value of 3 is going to be 3, because you're asking yourself how many numbers or how many units is 3 away from 0 is 3. Well, -3, absolute value of -3 would be 3 as well. How many units is -3 away from 0? Just 3. So when you apply the absolute value, the result is always going to be positive. It's always going to be the positive representation of that number. All right. So here's just a few examples. So the absolute value of 0.25 is 0.25. Absolute value of -7/8 is 7/8. Absolute value of -100 is just 100. So anything that you take the absolute value of will always result in a positive number. All right. So any questions on absolute value? All right. So opposites. Now, when you talk about numbers or opposite numbers, there's only 2 types of numbers in that regard, and that's positive and negative numbers. So if you have a +5, the opposite of that will be -5. Or if you have -10, the opposite of that is +10. So, you know, you only have positive or negative numbers. Negative turns numbers positive, so negative to negative. So you're actually saying what's the opposite of -7, which is +7. And then here, what's the opposite of negative? What is the opposite of +18, which is -18? So the negative sign turns it to the other symbol. All right. Also, make sure you watch your symbols. Notice we have the absolute value of -21. This negative sign, notice I have the arrow on this negative sign. This negative sign stays on the outside, is not affected by the absolute value. The negative sign on the inside of the absolute value is affected. So we talked about applying the absolute value to a number. Absolute value of -21 is just +21. But because we have this negative still out here, the final answer is going to be -21. So that negative on the outside is never affected by the absolute value. And then for the next one, I just want to emphasize the reason why I did this, just to emphasize the difference between having parentheses and absolute value. So here we had absolute value. Why is that working? There we go. Here we had absolute value, but here we have parentheses. So that means that these two negatives are going to affect each other. These two negatives don't touch each other. But because here we have parentheses, these two negatives do. So that the negative to a negative comes into play. And that's why we have a positive 21. So you most definitely have to make sure you're paying attention to your symbols when you're going about applying these negatives to your numbers. All right, questions on that?
What's the difference between on the example where it's negative 21 on the top? What's the difference between the straight lines and the parentheses?
Straight line or your absolute value. That comes back to right here, what we're talking about here.
Okay.
When you do absolute value of -3, the result is going to be +3. When you're doing just parentheses, which are the curved lines right here, that's just almost like just grouping together. That has no effect on your number at all.
Okay, understood.
So, yep, not a problem. Good question. So this is actually an application. This is just grouping symbols. So, yep.
Thank you.
Yeah, not a problem, not a problem. All right, anything else before we, let's see, we're gonna tell you at least touch on the next section, even if we don't finish it. Hey, hold on, what time the class end? Oh, we got plenty of time. So, all right, so let's look at the next one. Remember, this is 2.3 for us, not 1.3. So we're looking at exponents, order of operations, variables, and equations. All right. So exponents, when you have that superscript number up to the right, we have 2 to the 3rd power. So that is our exponent. The regular size numbers are base. So that means I want to multiply 2 times itself 3 times. All right, and that'll give us 8. So if I were to flip the positioning, in other words, have 3 squared, it's not going to give us the same result, because now I'm saying I want to multiply 3 times itself 2 times, which will give us 9. So of course the positioning, which one is your base, which one is your exponent, does matter. And we can see the difference here. All right. Anything to the first power is itself. So 7 to the first power is just 7. And then the same rule applies to fractions. If I have 3 to the 5th power squared, I said 3 to the 5th power squared, 3/5 squared. That's 3/5 times 3/5. And then you just multiply across. 3 times 3 is 9, 5 times 5 is 25. Or if you just want to square them individually, you can do it that way. 3 squared is 9, 5 squared is 25. So either way you should have 9 over 25. All right. Any questions? Everybody good? Scrolling up. Everybody okay? All right, order of operations. Let's get into this, because I be seeing too many things on Facebook wherein they have these order of operations and people getting it all the way wrong. So let's make sure we're good. And then you can answer the question and be all the way right, right? So PEMDAS, please excuse my dear Aunt Sally, or Shantae or Shaniqua, depending on who your auntie name. All right. We have grouping symbols, parentheses. You know, back in the day, they just gave you P for parentheses, but now we're gonna include all grouping symbols. So there's parentheses, brackets, or braces. All of those are just grouping symbols, like I just mentioned to your classmate earlier. Grouping symbols, they don't do any application, they don't change anything. They just hold, you know, or group together whatever's in that parentheses. Okay, that's going to get your attention first. Notice we have 4 tiers of operations. Your first tier, or in other words, what should get your attention first are your grouping symbols. The second thing that should get your attention are your exponents. That's what we just finished talking about. The third thing should get your attention is multiplication or division. So where a lot of people go wrong, and this is what they do wrong in Facebook, is that they will take that order of multiplication and division as the strict way as you're supposed to do it. And that's not necessarily the case. Multiplication and division are on the same level. So if division comes first, you're supposed to do division first. You look at it from left to right as it goes into your problem. I'll show you an example of it in a second, but they're on the same level. So you do those from left to right. Multiplication doesn't necessarily come before division unless it comes first in the problem. Same thing with addition and subtraction. That's the last level. That's the last thing you look for, to do. Once again, if it's in your grouping symbols, though, you do that first. Whatever's in your grouping symbol, you simplify that first. All right. So a simple example of what I'm talking about is right here. 18 divided by 9 times 2. So once again, multiplication and division, you do those from left to right. They're on the same level. So now if you were trying to hold true to just the way it comes in the order of PEMDAS, 18 divided by 9 times 2, you would do 9 times 2 first, then 18 divided by 18, which is 1. Now, just because you come up with an answer does not mean it's the correct answer. So that's where a lot of people make a mistake. They say, oh, well, I got a solid number, I got to be right. That's not necessarily the case. You do division and multiplication from left to right as you see it. So the first thing you're supposed to do is division, because it comes first as you're reading your problem from left to right. 18 divided by 9 is 2. And then now multiplication is left. 2 times 2 is 4. So this is the correct way of doing this problem. So make sure we're okay with that before we add more to it, do more problems with order of operations. There are only 4 levels to this. Multiplication, division are on the same level. Addition and subtraction, same level. All right, let's scroll up. All right, let me erase some of this stuff and we'll walk through it. All right, so we have 6 divided by 3 plus 5 squared. So going according to PEMDAS, you look P for your grouping symbols, parentheses. We don't see any grouping symbols. So the first thing we want to do, first thing we should do in this problem is our exponents. This is the next letter. So 5 squared is 25. That's 5 times 5. So that's 6 divided by 3 plus 25. Next, 6 divided by 3, because division comes before addition in our order of operations. 6 divided by 3 is 2. And then 2 plus 25 is 27. All right. Next one, 25, not 25, 20 divided by 5 times 2 times 4. So we have 20 divided by 5. It's going to be 4. And 4 times 4, 16. All right, any problems with that before we look at another one? All right, so for this one, 2 times 12 plus 3, 2 times the quantity of 12 plus 3, divided by the absolute value of 15. So do what's in the parentheses first. So that's 2 times 15 over the absolute value of 15. Then we can do multiplication. 2 times 15 is 30. No, I'm just doing it step by step. The more comfortable you get with doing this, you can do things at different times, multiple times, and all that stuff like that. but I'm just doing things step by step. So that's 30, and then apply the absolute value to your negative 15, which is positive 15.
Why do you keep putting those straight lines on the bottom of the fraction?
Well, it was initially given to us. That was a part of the original problem. And so that's the absolute value. So I hadn't applied it here yet, and I hadn't applied it here. I didn't apply it until I got right there.
Okay, I didn't even notice it on the original problem. I'm sorry, man.
Oh no, you're fine. Ask the questions. I'd rather you ask versus not asking.
I'm gonna have a lot of them.
Not a problem. All right, so that's 30 divided by 15. So that bar represents division. Just another way of representing division. So 30 divided by 15 is 2. All right, any problems, any problems? All right, let's look at oh, this one. I was just showing that 2 times. I was just saying that if the bar, somebody asked me about the bars, I think in the previous class. So I'm saying that if the bars weren't there, then that negative sign would still be there. And then 30 divided by negative 15 would be a negative 2. So that was just, that's what this was about. That was pretty much a different problem because it didn't have the bars in the denominator. So your answer ended up being negative 2 instead of positive 2. So I probably should put an example of something there. Okay. So here we have 3 over 2 times 1 over 2 minus 1 over 4. No, never mind. So yeah, 3 over 2 times 1 over 2 minus 1 over 2. 3 over 2 times 1 over 2 minus 1 over 2. I think I said 1 over 4 first. Anyway, 1 over 2. So first thing we want to do is multiplication. Multiplication comes before subtraction. So 3 over 2 times 1 over 2. So you do not need common denominators to multiply or divide fractions. So all we did I not write it down here? Okay. So all we did was multiply it across. And so that's how I got 3 over 4. All right, so that's how you have 3 over 4 minus 1 over 2. And now notice what I say in the green, but you must have common denominators to add and subtract fractions. So they do come into this section with the idea that you do have some pre-knowledge, whether it comes to adding, subtracting fractions, multiplying, dividing fractions. So if you have questions, make sure you ask. If you need to get a Zoom session outside of this class, make sure you email me. Or if you want another lecture or video on add, subtracting fractions, multiplying, dividing fractions, I have those as well. I can always shoot you that link, whatever supplemental instruction you want to make sure that you're comfortable moving forward. Make sure you get with me on that. But they do just like adding, subtracting sign numbers or multiplying, dividing sign numbers. They are, they do come into this section with the expectation of pre-knowledge. So if you have holes in your, whether it be algebra or arithmetic, make sure you get with me, shoot me that email. And like I said, I can either send you a video of something that I've done before on those topics, or, we can meet outside of class time. So like I said, you must have common denominators in order to add, subtract fractions. So common denominator, and I'll try to give you as many notes as possible in this section as we do it to, make sure you're good. So your LCD is the smallest number that each denominator can divide into evenly. So when we look at the 4 and the 2, the smallest number that both of them can divide into would be 4, because 4 can divide into itself, 2 can divide into itself. 2 can divide into 4. And so that's what we did right here. We let that common denominator be 4. That means I want both my denominators to be 4. The first fraction is okay because it already has 4. And then you ask yourself what times 2 will give you 4, and that is 2. But whenever you're dealing with that, whatever you do to the bottom, you have to do to the top. So you multiply both top and bottom by 2 in order for us to have a denominator of 4. So that's how we got 2 4s right here. So like I said, that's how you get that common denominator. Yeah, in order to be able to add and subtract fractions, You need common denominators. Once you establish what that common denominator will be for you, you have to multiply the denominator and numerator times whatever it takes to turn that denominator into what you establish as the common denominator. So we multiply top and bottom by 2. So 3/4 minus 2/4 will be 1/4 as our final answer. All right. Questions before we look at another one? All right. So this next one, we have 3 times the quantity of 4 plus 2 times the quantity of 10 minus 1. So notice we have grouping symbols here, and we have grouping symbols embedded inside of another set of grouping symbols. And so whenever you have that, you always want to work your way inside out. You want to do your innermost grouping symbol first. So we have 10 minus 1 is the first thing that should get our attention. So 10 minus 1 is 9. Still working inside of our brackets. We have 4 plus 2 times 9. So the 2 times 9 is what will get our attention next. And that's 18. Still haven't finished simplifying as much as possible in the bracket. Now we do 4 plus 18, which is 22. And now we can finish it off. 3 times 22, 66. Any questions? Make sure we're good. All right. Next thing they talk about is variables. They give us x equal to 3 and y equal to 2. And we still have to apply the absolute, not absolute value, order of operations here. They give us this first expression of 2x, minus y. And what you're going to do is plug in the value that you give us for x, plug in the value that you give for y, then perform the order of operations. So we plug in 3 for x and then 2 for y. So that's 2 times 3 minus 2. Two times 3 is 6. And then 6 minus 2 is 4. That's our final answer. All right. Do the same thing for b. We have x squared minus y squared. So we plug in 3 for x, 2 for y. So 3 squared minus 2 squared. 3 squared is 9. 4 squared is 2 squared is 4, and that's 5. All right. Any questions? Any questions? Almost finished. All right. Hold on 1 second. Let me see how much is left. Okay. Okay. So they do a little bit on equations. An equation is a statement that 2 algebraic expressions are equal. So an example of that is x plus 5 is equal to 8. X plus 5 equal to 8. Just 2 algebraic expressions are equal. Now the solution is going to be a value or values that will make that equation true. So we're not solving yet. They're just introducing you guys to equations. But when we get into solving, then you want to ask yourself, when is this statement true? When is x plus 5 equal to 8? And that will be when x is equal to 3. And you can always plug in the value into your original equation to see if it works out, to see if it gives you a true statement. In this case, like I said, x equal to 3 would be the solution because 3 plus 5 is equal to 8. All right. And that's what the next exercise asks us to do. It says decide whether 2 is the solution of the equation 3x plus 10 equal to 8x. And always, if I scroll up too far, too fast, let me know. So you would just take the 2, plug it into the equation that they give for x. So every place you see x, you put 2 there. So notice we had x in 2 different places. So we need to put 2 in both of those spots. So it's 3 times 2 plus 10, and then 8 times 2 on the other side of our equation. And you simplify both sides as much as possible. And if both sides end up equaling out to be the same thing, then it is a solution. So on the left side, 3 times 2 is 6, plus 10 is 16. And then on the right side, 8 times 2 is 16. So it checks out. That means 2 is a solution. All right. Any questions? Any questions?
Can you scroll back up to the equation definition?
Yep. Right there.
Thank you.
Not a problem. Trying to check out something real quick. Was in this other shell. Okay. Oh, where my notes go? Can't get it back up. Okay, cool. All right, everybody good for this last thing? We'll finish it off. All right, so translating phrases to algebraic expressions. So I know the book that I had, the keywords were on page 23. I have to look that up. I'll look it up and find it. But if you go to that section, it should be what 2.3. It should be in that section. Like I said, that was for the book that we were dealing with before. They changed the edition on me, so it'll probably be a different page now. But they have keywords and key phrases that we'll use here. So here it says write an algebraic expression. So they give us the sum of a number and 3. So sum means addition. So we're just talking about the sum of a number and 3. That's just going to be x plus 3. Or you can write 3 plus x. You know, addition is commutative. 5 plus 3 is 8. 3 plus 5 is 8. So either order. When it comes to addition, is okay. But x plus 3 or 3 plus x would be the sum of a number in x, the sum of a number in 3. So watch directions, be careful, because they probably would tell you to use x or use n. Make sure you use the proper variable that they tell you, because in my math lab, it's programmed to receive a certain type of answer. So if you use a variable that they're not programmed to use, then it would mark it wrong, even though you did, may have done it right. So make sure you use the variable they tell you to write. All right. Twice the number is multiplication, so that'll be 2 times x. Or you can even use the dot. Now, that's not the simplest way of writing. The simplest way of writing is 2x, but it should accept 2 dot x. But that's if they give you that as an option. So, but 2x is the most simplest way of writing it. All right, next one, 5 times a number increased by 7. So 5 times a number is 5x. And if you're increasing something by 7, you're adding 7 to it. All right. Everybody good for this last exercise? Go ahead. All right, so this last one, notice it says write each as an equation. This one says write each as an expression. Expression does not have an equal sign. An equation has an equal sign. So be careful with that. If you want to write as an equation, that means there is an equal sign that involves somewhere. But when you're writing as an expression, there is no equal sign. So just throwing it out there. So here we have the quotient of 15 and a number is 4. So let me write that almost like a S. Right there, better. So the quotient of 15 and a number is 4. So quotient means division. So that's why I wrote 15 over X. 15 and a number, 15 over X. And then is your equal sign. And 4 would be what follows. Any problems with that? All right. So let's look at B. Sorry, guys. Sorry. So 4 times the number added to 17 is not equal to 21. So I've noticed this time it says is not equal to. So 4 times the number is 4x added to 17 is plus 17 is not equal, is the equal sign with the slash. And that's 21. All right. Questions on anything that we've done? All right. So some questions may not show up until you actually get in there and do some work, and that's understood. And that's all right. So make sure you get in there, try the stuff out, see if you have any questions, issues. Every day is an opportunity for questions. Before a test, we will always have a review day as well. And then also make sure that if you have any issues, feel free to email me and make sure that we make sure you're straight. Now, as far as homework is concerned, it's on you. I would say, if you have time to do it tonight, go ahead and knock it out while it's fresh. So just in case anyone didn't see one of your classmates wrote in the chat, did we have homework tonight? It's really on you. I haven't set the due date yet. As we get closer to closing out chapter 2, then I'll put a due date out there. And that's when everything will be due by that due date. Right now, there is no due date, so you don't necessarily have to do anything tonight or even tomorrow, really. But you don't want to wait too long because, you don't want this stuff to leave you if you haven't seen this stuff in a while, you know what I mean? So it is, to me, in best practice to go ahead and get in there between today and tomorrow and start knocking this stuff out. But, it's all about your time and what you have available to you as far as being able to get to the homework. If you don't do anything by next class, there is no penalty because there is no due date set. But once I set that due date, that's when that's my marker to get everything done before that due date. Let's see. Okay, somebody said they do have a question. What's the question?
Well, I can wait until class is over. This is about the course.
Man, class over. No,
Oh,
it's playing. Yeah, but it is over. But your question about the code may help somebody else. But yeah, as far as lecture, we over with the lecture. Yeah, so you can go.
Okay. All right. So I did have an issue first day when I bought the code. But then when I called, they actually helped me. But now I noticed that you gave a different number. Will that still be the same thing? Because it says fall for 2021.
Have you tried registering for it?
Yeah, I was doing it right before you got on. I didn't go any further.
I'm talking about with the new one.
No, I haven't done anything with it.
Okay, try registering with the new one and see if it'll let you in.
Okay.
Yeah, if you want, you can do it right now and I'll stay on. and let's see what happens. It's up to you.
All right, so it pretty much looks like the same thing that you were showing us in the beginning.
Okay.
Like on the left, it says my lab math, my course this, course home, and syllabus and stuff like that.
Okay. So it did let you in?
Yes, but it's a whole different number. Oh, yours then? Go ahead, baby.
Mine's not me in at all, so I don't know.
You said it's not letting you in at all? What is it saying to you?
I could prove it.
And I just want to go back. So you are using the 22843, right? Tucker 22843.
They didn't even put the code in either, so I don't know what's going on. They didn't put the code in either.
What you mean? So you went and you did register?
I did register, but they didn't let me put the they didn't let me put the code in. I don't know why.
Sounds good. All right, hold on. So it sounds good. Let me go to say this. For those of you that are good, you don't have the lecture. We're done with the lecture today. I'm just clearing up some math lab issues. If you don't have any math lab issues, you're most definitely free to go. I appreciate your time. I will see you on Thursday. All right. So have a good one. So Ms. Davis, you said that when you go to register, let me do this. I want to make sure in the process that we're talking
Yeah, when I
about.
registered, it doesn't say nothing about the code.
Now, let me ask you this. So let's go here. As far as the process, I want to make sure we go with the process. So you get here to register now. So when you get here, do you type in the course ID?
See, that's the part I didn't get to.
So now,
See.
how are you getting there? So let's go back to the first page. Oh, let's go right here. So you go to student and you hit register now as a student.
Yes, I hit student already, and I already got a login, so I hit sign in already.
Yeah. Do the register first. Because see, when you register and then you type in the course ID, I'm just gonna hit this one. It will give you. Then you can put in.
So I gotta make a new account.
No. You don't have to, because see, look
So
right here. See right here, it says Pearson account. You can put in your information right here, but you want to be able to put your course ID in first. So you can register yourself for the course. I think you can do it your way as well, but I know this way works just straight up. You know what I mean? Because I think you still can sign in sign up for a course after you sign in. But I know this way, this registers you for the course, then you can sign in with your information. Okay. So now I'm.
Yeah, I didn't do that. That's why I guess I have this 396 number.
Now the 396 number, that was the original one, remember? But I sent you another email with a new one.
Right, you sent that after I already resolved the issue, so I didn't know what I needed to do.
Yeah, me too. You said that after I already had logged in.
Yeah,
that's the problem.
Just go back and re-register.
Oh.
Yeah. Just go back and do the process again, and let's see what message they give you after that.
So register again.
Okay, let me.
So go back to student, like start all over.
Yeah, and let's see what happens. Let's see what goes on.
Let's start all over again. Okay, hold on. Let me see how can I get out of this. Okay.
Just go ahead and register.
All right, may I please get that number again?
Never. All right, hold on. I know it's Tucker.
I'm gonna do it while you up here.
Let me see.
Hold on, I'm about to log in now.
I'm trying to find a number. I know it's 22 something.
So what's happening? My math.
There you go, right there.
Thank you.
22843.
Okay, hit student. Then.
Okay, so it brings me back to, I guess, the same thing. It says username and password.
Mm.
Oh my God, what's going on? It's not working. Okay, now it's asking for the access code.
Or you can.
So the access code part don't work, right?
Well, that's what I'm trying to see what message is it telling you guys so I can know how to move forward.
Okay, because when I call the lady, she goes, you need to go back to Barnes and Noble and let them know that the course is the wrong course that they gave you. And then she placed me on hold and she goes, oh, don't worry about it. You don't have to go to Barnes and Noble. I fixed your issue. So
Yeah, that's what I'm saying, because they can switch it out. They can do that. Now it's like depending on how you present your issue, they may, you know what I'm saying? They may say, oh, well, it's a Barnes and Noble issue. But if you know, that's why I say that depending on what you tell me, I know what I can do. So that's why I need to see what message or what your issue is. So is it letting you in to get full access?
I'm putting it all in there.
Mine's still not letting me in. I don't know what's going on. Mine's still not letting me in.
So what is it
Like,
telling you,
it's
Ms.
not.
Davis?
On the page that says turn poppers up blocker. That's what I'm on. It says
What
turn a pop-up blocker. That's what I'm on.
Yeah, well, you got to either turn it on or turn it off so you can go to the next screen.
So
Matter of fact, I don't need to be recording this. I can stop the record.
Mr. Tucker, I got some